Okay, now we're dealing with a piece of cardboard being made into a box. What we're going to do is we're going to take out and cut squares from each of the corners. Gives us flaps to fold up. We're trying to find which cutout, how big these cutout squares have to be in order to maximize the volume of the box. So we have, for the box, being a rectangular prism, the volume's length times width times height. And in the diagram that I provided, the length, 60 minus 2x, because that cardboard is 60 centimeters long, we've cut out a corner from each corner, that being x twice. The width, same thing, and the height is x. Before we go any further, I'll deal with the domain right now. The domain of x, the cutouts, has to be a little bigger than 0. We have to cut out something, otherwise we have nothing to fold up. And less than 30, because we're cutting out from both sides, so we can't cut out the whole 30 centimeters on each side. Now looking at the volume equation, that's complicated. It's got 3 terms multiplied together. So like with the last one with that sheet pen, I'm going to take and I'm going to simplify this. So I'm going to FOIL out those 2 first brackets. And then, to make things even easier, if we're taking the derivative, I'm going to multiply the x in as well, and collect my like terms. Now that we've got the volume function simplified a bit, we can take the derivative, we need to find the critical number, so we'll set that equal to 0. And from there we can go with the quadratic equation, quadratic formula, to solve this. But if we take a look at all 3 of those terms, they're all divisible by 12. Just to make things a little bit easier. And in fact, this is also factorable. So just to make it look a little nicer, I'll put this in order. We need 2 numbers that multiply to 300 and add to negative 40. Negative 30 and negative 10 do the trick. Split. And we have x equaling 30. As well as x equaling 10. Now looking at these 2 answers, comparing them to the domain, x equals 30 doesn't fit in the domain. So we're going to reject that one. We can't make a 30 centimeter cutout. If we did, the cardboard would just fold up onto itself. So we have one critical number. We can avoid the test for the maximum because we don't have the endpoints of the domain to check because they're not included. So we know that the cutouts must be 10 centimeter squares. And looking at the question, that's all that we needed to find. The question wasn't asking us to find what is the maximum volume, just what size of cutouts would be needed to maximize the volume.